Hi guys, Mr. Mackey here. Now this is day 3 of Triangle Week and I set you this puzzle to do last night. We have 2 right angle triangles on top of each other, we have 2 sides of one and one of the sides at the bottom. I need you to find the hypotenuse of this triangle. Now for this we are going to be using Pythagoras' theorem, but we're going to have to be using it more than once. And don't forget, whenever we're using Pythagoras or anything related to triangles this week, you will need your calculator. So let's get cracking on. So how do we find this side of that triangle? Well, when you look at the rules I gave you here, you will have to do the hypotenuse, which is 5 squared, minus a, which is 3 squared, which becomes 25, minus 9, and that will get us 16. So b squared will be 16. So how do we find b? Well, you square root it in your calculator. So you get your calculator, you square root 16 and you will get 4 centimetres. But you're probably asking me, why on earth are we working out the line for this triangle? We're meant to be focusing on this triangle. How's that meant to help us? What if I was to tell you that the line for this triangle is the exact same for the line for that triangle? Because they're joined at that. They're going to be exactly the same length. So, all we now have to do is do Pythagoras to find this side, the hypotenuse of this triangle, because now we know A and B. So, let's say that A is 7, so we do 7 squared plus B squared, so it's 4 squared. That will become 49 plus 16, that will get 65. So C squared is 65. How do you find C? You root 65, so you do that in your calculator. And let's do it to 2 decimal places. So the actual answer will be 8.06 centimetres. And that's how we find the hypotenuse of that triangle. Now before we start today's video, I have a confession to make. It turns out that on Monday's video I made a bit of a fatal mistake. Now I'm going to quickly show you a clip from Monday's video and I want you to try and identify what stupid thing I did. Triangle, right, this has to be longer. Now this side is opposite to the hypotenuse, so it's known as an opposite side. Now this side, okay, is quite next to the hypotenuse, so this is known as adjacent to the hypotenuse. Did you figure it out? Well, it turns out that I labelled the sides of this right angle triangle incorrectly. I said that this side was opposite because it was opposite to the hypotenuse, and this side was adjacent because it was next to the hypotenuse. That is wrong. It turns out what determines opposite and adjacent is this angle here. Because this side is opposite to the angle, it turns out that this side is the opposite side. And because this side is adjacent to the angle, this side is adjacent. Now, the good news is this mistake did not affect Pythagoras' theorem. Anything we did the past couple of days, it did not affect it at all. I wanted to address this now because it's paramount that you understand this mistake before we start today's video. Okay? I'm holding my hands up. Yes, I did make a mistake, but it is okay to make mistakes. Everyone does it. Teachers make mistakes all the time. I've made mistakes when I was a teacher at secondary school. It happens. What makes you a bigger person is if you admit to those mistakes and you learn from those mistakes. And I've learned from that mistake and I'm willing to admit that I'm not perfect. But I can assure you that I hopefully will not make any more mistakes again. And if I do make a mistake, comment below in the video and I'll see how and I will completely hold my hands up and apologise. Hopefully I won't make too many mistakes, but this is how it should look and this is absolutely important for what we are doing today. Now today we're going to be finding missing angles and missing sides from right angle triangles. Today's episode, we're going to be finding missing angles. Tomorrow's episode, we'll be looking at finding missing sides without Pythagoras. Now, for this, we're going to be using something called SOHCAHTOA. Now, this actually means 3 different things you can use in your calculator. So let me tell you what they stand for. So, the S stands for sine. So if you look at your calculator, you can see a SIN here. That's what sine stands for. But we use sine when we have an opposite angle and a hypotenuse. So you notice sine or hypotenuse. So that's what they stand for. The C stands for cos or cosine, the big way of it. And cosine you find is right next to the sine on the calculator. And cosine is when you have an adjacent and a hypotenuse. And the final one, TOA, the T stands for tan. And that is the final one right next to cos, that's the tan. And that stands for opposite over adjacent. So you're probably wondering, what on earth does all this information mean? How can this help us find a missing angle or side? Well, I'll show you. Let's say I have an angle here, and I'm going to label it X, and I have a hypotenuse of 13 and an opposite side of 12. How do we find this angle? So, what we write is that sine X equals our opposite, which is 12, divided by a hypotenuse, which is 13. So we divide our opposite by our hypotenuse. So the question I have is then, how do we find that missing angle? We've just written 12 over 13. I doubt that angle is going to be 12 over 13. How do we do it? Well, this is when our calculator comes in. So what you do is, if you look right at the top of your calculator, you'll see a button with the yellow word shift over it. You press that. And then you press above, then you press the sign straight afterwards. So you press shift, then you press the sine button, because we're doing sine because it's opposite over hypotenuse. And on your calculator, it will then say sine minus 1. What we've done is we found the sine of the angle. We are now finding the angle, so we're reversing the process. We are now finding the actual angle. So now you enter 12 over 13. Because that's what we had. That was the sine. We're now reversing it. So if the sine of the angle is 12 over 13, the actual angle to 2 decimal places, I'm going to do it as, is 67.38. But that's still not complete. How do we complete it? Well, what we do, put a little circle at the top of it, because it's degrees. So the missing angle here is 67.38 degrees. But what if we have one like this, where we don't have the opposite, instead we have the adjacent? We're still finding this angle though. So we have an adjacent of 8, a hypotenuse of 10, and our missing angle. So what we write is, because we have an adjacent and a hypotenuse, we're going to be focusing on K. And K, the C, stands for cos. So cos X equals our adjacent, which is 8, over our hypotenuse, which is 10. And how did we find the angle from the sine problem just now? We do exactly the same here. We press shift, then the cos button, because it's cos minus 1, and then we enter the answer, 8 over 10. And then to 2 decimal places, what will that get us? Well, it says 38.869. And remember what we did about rounding? We round it up because the 9's bigger than 5. So our missing angle is actually 36.87 degrees. And that's how we use cos to figure it out. But now let's do the final one. We have an opposite and an adjacent. And we need to find tan from that. Because it's opposite over adjacent, we use TOA. So tan x equals 5 over 3, because we're dividing our opposite and an adjacent. We now do the same thing in our calculator. Shift, we press our tan, so it's tan minus 1, and we enter 5 over 3. And we will get to 2 decimal places the angle 59.036, because at 6 we round it up. So our missing angle is 59.04 degrees. And that's how you use SOHCAHTOA to find missing angles. So the previous 3, I've told you when we use SO. I've told you when we use CAT. I've told you when we use TOA. So for this, I'm not going to tell you. I'm going to let you figure this out for yourself. I've got a hypotenuse of 20 centimetres and an adjacent of 12 centimetres. So the question I have is, firstly, do we use SO? SO is when we have an opposite and a hypotenuse. We have a hypotenuse, but we don't have an opposite. So we do not use SO. Second question, do we use CAT? Well, CAT is when we have an adjacent and a hypotenuse. We have a hypotenuse, we have our adjacent. So we're going to be using CAT in this. So, what do? Well, remember we write cos x equals our adjacent, which is 12, divided by our hypotenuse, which is 20. So to find x, you go on your calculator, you press your shift at the top, you press your cos here, then you enter 12 divided by 20, your adjacent divided by hypotenuse, and you will get your missing angle, which is 53.13 degrees. And it's that simple. So here is your challenge for tonight. I have a right angle triangle, and I want you to find for me this angle. How do we find it? I will admit there is some information that I have not given you in any of my videos that will help you work out this answer. But it is stuff you should have known since primary school. Next week's theme is angles, and I will be doing 7 days fully on angles. That is a little clue to how this could help us with this question. But for now, I want you to try your best to find this missing angle using SOHCAHTOA. Good luck, and tomorrow we're going to be figuring out how to find missing sides with SOHCAHTOA. Good luck, don't forget to subscribe, and keep our children learning. Thank you.